So good afternoon everyone. So for today our topic is all about rocket propulsion, and these are presented by Karen Bilikmuan and my partner Raslyn Manganuhoy. So first, let's define what is rocket propulsion. So these are propellants and defined as a substance or mixture substances of an explosive nature in solid and liquid state that burn exothermally without created with atmospheric oxygen and form of a large volume of gas. And now let's proceed to thrust. So when we say thrust, these are propulsive force of a jet or a rocket engine. So typically, a rocket engines produce two types of thrust. So these are the pressure thrust and the jet thrust. So in a pressure thrust, it generates higher pressure behind the rocket, and it has this equation of exit pressure minus ambient pressure times area. While in a jet thrust, it pushes the rocket forward by throwing gases out of the back. So it has this equation of mass flow times exit velocity. So by calculating the total thrust, you just need to add the pressure thrust plus the jet thrust to get the value of the total thrust. So keep in mind, in producing or generating a thrust will depends on fuel, rocket nozzle, and rocket altitude. So now let's tackle the different ways of generating a thrust. And for the first one, which is the internal combustion engines. So these internal combustion engines are usually found in cars. So they are small but require an oxygen supply. So nakikita nyo ngayon, ito ay isang halimbawa ng makinaryang sasakyan. At ito ay may 10 parte, katulad na lamang ng cylinder, cylinder head, the piston, piston rings and piston pin, the connecting rod, the crank in the crankshaft, the inlet valve in the exhaust valve, the spark plug, and lastly, the fuel injection pump, which is madali nyo na lamang siyang ma-identify kasi meron ng mga numero sa bawat parte. And next is the jet engine. So jet engines are usually found on fast airplanes. So they can generate a lot of thrust, but they still need an oxygen supply. So this is the example of jet engine, and usually jet engine has 4 parts, and these are the compressor, the bypass fan, the combustor, and lastly the turbine. And lastly, the rocket engine. So this generates to escape Earth's gravity and often carry their own oxidizer so that they can work in space. So this is the image of rocket engine, and as you can see, it has 4 parts, and there are the compressed gas, the petrol, the oxidizer, and the nozzle. So in rocket propulsion, pressure and forces are involved. So these pressure forces are the force applied perpendicular to the surface of an object. So as air wants to go from higher to lower pressure, so the pressure force would be pressure 1 minus pressure 2 times area. And remember that pressure is equal to force divide area. So next is the momentum force. So these are the force that exists in moving object. So the momentum force of a moving object is calculated by multiplying its mass by velocity. So it says here that if you throw something out one way, it will push you the other way. And if the rocket nozzle throws gases down, the gases will push the rocket up. So this is how rocket nozzles function. So if nozzles push on high gases and accelerate them out the back, in return, the gases push on the nozzle and accelerates it forward. So next is the control volume. So it is usually easy to study gas flows using the control volumes. So only forces on the rocket could be calculated by only looking at the control surfaces. So it has the equation of pressure force is equal to exit pressure minus ambient pressure times exit area. And the next one, which is isentropic nozzles. So isentropic nozzles has two different types of nozzles, and these are the converging and diverging nozzles. So interesting, in converging to diverging nozzle will depend on chamber pressure, ambient pressure, and nozzle shape. So in converging section, so these are the tubes with an area that decreases from the nozzle entry to the exit or the throat of the nozzle. So as the nozzle area decreases, the flow of the velocity is increases, with the maximum flow velocity occurring at the nozzle throat. And it says here that in upstream of the nozzle, in the combustion chamber, the gas velocity is small. So all fluids like water, air, or etc. accelerate through a converging section, and the fastest way that they could get in the converging section is the Mach 1. And while in a diverging section, this is a tube where it pinch in the middle, so making carefully a balanced and asymmetric hourglass shape. So they are widely used in some types of steam turbines and rocket engine nozzles, and also it is used to see in a supersonic jet engines. So in continuation, in diverging section, if the gases reach Mach 1 in converging section, then they will continue accelerating in the diverging section. However, if the gases did not reach in Mach 1 in the converging section, then they will decelerate in the converging section. And this is why our water bottle rockets only had a converging section. So next is the over and under expanded gases. So when an overexpanded gases flow passes through a nozzle, the higher atmospheric pressure causes it to squeeze back inward and separate from the walls of the nozzle. However, in the underexpanded gases, the opposite situation, in which the atmospheric pressure is lower than exit pressure. And now, let's proceed to the water bottle rocket debriefing. And it has a question here that, why did rocket filled with water go higher than those filled with just air? It is because that water has a greater mass that contributes to a greater thrust. So usually the rocket is made from 2-liter soda pop bottles. So before launch, the bottle is filled with some amount of water, which acts as the propellants for the launch. And since the water is about 100 times heavier than air, so the expelled water produces more thrust than compressed air alone. So that is why a rocket that is filled with water will fly much farther than a rocket that will only filled with air. And next, which is the specific impulse. So it is used to classify how well a rocket performs. And there are two types of specific impulse, the low and the high specific impulse. So in a low specific impulse, it needs a lot of fuel to achieve the thrust, while in high specific impulse, it do not need as much fuel to achieve same thrust. And it is calculated by specific impulse is equal to thrust divide mass of flow times gravity. And here is the example to calculate the rocket thrust and the acceleration.
To continue, let's talk about the 5 types of rocket engines: the pressurized air, solid propellant, liquid propellant, nuclear, and the electric. So now first, let's discuss the pressurized air or compressed air. Compressed air leaves out of the back of the rocket. So when the rocket is placed on the launch tube, the body tube becomes a closed pressure vessel, and the pressure inside the body tube equals the pressure produced by the air pump. And in that case, the air pushes the rocket forward. The flight of a compressed air rocket is similar to the flight of a ballistic shell or a bullet fired from a gun. And the launch of a compressed air rocket proceeds in 3 stages. First, the pressurization of the body tube. Second, the initial acceleration along the launch tube, and the expulsion of the compressed air from the rear of the rocket. And now, let's move on to the second types types of rocket engines, the solid propellant. These are the simplest of all rocket designs because they consist of a casing, usually steel, filled with a mixture of solid compounds like fuel and oxidizer that burn at a rapid rate, expelling hot gases from a nozzle to produce thrust. When ignited, a solid propellant burns from the center out towards the sides of the casing. There are two families of solid propellants, the homogeneous and the composite. Composites are composed mostly of a mixture of granules of solid oxidizers such as ammonium nitrate, ammonium dinitramide, ammonium perchlorate, or potassium nitrate, and a polymer binding agent. Homogeneous, a single, double, or triple bases depending on the number of primary ingredients are homogeneous mixtures of 1 to 3 primary ingredients. Solid propellant has advantage and disadvantage. The advantage is that solid propellant rockets are much easier to store and handle than liquid propellant rocket, and it has high propellant density that makes for compact size as well. And there's no propellant pumps are required, thus the rocket engines are less complicated. And the disadvantage is that unlike liquid propellant engines, solid propellant motors cannot be shut down. Once ignited, they will burn until all the propellant is exhausted. And the next type of rocket engine is the liquid propellant. In liquid propellant, fuel and oxidizer are both stored separately in liquid form, and it is pumped into a combustion chamber where they are mixed and burned. And the combustion produces great amounts of exhaust gas at high temperature and pressure. The hot exhaust is passed through a nozzle which accelerates the flow, and the thrust is produced according to Newton's third law of motion. The amount of thrust produced by the rocket depends on the mass flow rate through the engine, the exit velocity of the exhaust, and the pressure at the nozzle exit. All of these variables depends on the design of the nozzle. The smallest cross-section area of the nozzle is called the throat of the nozzle. The hot exhaust flow is choked at the throat, which means that the Mach number is equal to 1.0 in the throat, and the mass flow rate m dot is determined by the throat area. The area ratio from the throat to the exit AE sets the exit velocity, VE, and the exit pressure, PE. The exit pressure is only equal to free stream pressure at some design condition. We must therefore use the longer version of the generalized thrust equation to describe the thrust of the system. If the free stream pressure is given by PO, the thrust F equation becomes F equals m dot times VE plus PE minus PO times AE. And the next type of rocket engine is the nuclear propulsion. In the nuclear propulsion, nuclear reactor heats working gas that is accelerated through a nozzle. It also includes a wide variety of propulsion methods that use some form of nuclear reaction as their primary power source. But there is a disadvantage of nuclear. Disadvantages of nuclear rocket includes radiation effects by the nuclear reactor and the high weight of the engine assembly. Several studies over the past few decades have recognized the need for advanced propulsion to explore the solar system. And the last type of rocket engine is the electric propulsion. Electric propulsion is a class of space propulsion which makes use of electrical power to accelerate a propellant by different possible electrical and magnetic means. The use of electrical power enhances the propulsive performances of the electrical propulsion thrusters compared with conventional chemical thruster. Unlike chemical systems, electric propulsion requires very little mass to accelerate a spacecraft. The propellant is ejected up to 20 times faster than from a classical chemical thruster, and therefore, the overall system is many times more mass efficient. And there are two types of electric propulsion, the arc jet and the ion thrusters. In arc jet, electricity is used to superheat the gases, while the ion thrusters, it ionize or charge atoms are accelerated through an electromagnetic field. That is all about the types of rocket engines. In addition to our discussion about the rocket propulsion is that in rocket propulsion, matter is forcefully ejected from a system, producing an equal and opposite reaction on what remains. And yes, that ends our discussion about the rocket propulsion, and we do hope that you've learned something. Thank you!